Hello, students. Thank you. Welcome back. We're going to continue today with Lipids Part 5. Lipids Part 5. Now, when we stopped last, we talked about the triglycerides and the fats. On this one, does anybody know what this is? Let's see if we can get a pen here. Okay. We have this. Anybody have any idea what this is? This structure is, this thing is I'm drawing. A what now? A cell. This is a cell, exactly. And within the cell, going around the cell, you have this thing, the cell membrane. And that membrane looks like this. It has these structures in it. Okay. Does anyone know what these little lollipops are that are in a cell? Phospholipids. And so this lecture is going to be devoted to learning 8 phospholipids, or the common phospholipids found in the cell. We're going to learn the structure of those phospholipids and where they're found in the cell. So let's draw our parent compound. Okay? And our parent compound is going to be, our parent phospholipid is going to look like this. We're going to have glycerol, 1, 2, 3. We're going to have our ester linkage here to our fatty acid. Since I don't care what fatty acid this is, I'm just going to put a wavy line there, because I don't care what acyl group that is, what fatty acid that is. Is that okay with you all? Excellent. So that's 1. Another ester linkage, 2. And on the 3rd carbon of glycerol, we're going to have a phosphate group. That's going to be our phosphate group. And so this parent phospholipid is called phosphatidic acid. All of the phospholipids are based on phosphatidic acid. That's the parent compound. The parent compound is phosphatidic acid. This is the parent compound. Of all of our phospholipids, phosphatidic acid. Everyone okay with that? Now, I'm going to do something here. Since all phospholipids have a generic structure that looks like this here, so that's usually how phospholipids are drawn, you know, a circle, like a lollipop with 2 sticks. I'm going to make all of our phospholipids, I'm going to draw them like this here. I'm going to have this part, and then these would be our 2 tails. And so, if I draw this here, this is going to represent phosphatidic acid. That way we won't have to draw this every time. Does that make sense? Okay. So we'll be able to attach different things onto this phosphatidic acid to change our head group. So what you can do here, if you add, you can actually attach something here to change phosphatidic acid to our other phospholipids. Everyone okay with where we're going so far? So we're going to be learning the 8 common phospholipids found in cell membranes. Okay. Now, let's look at some bonds first before we get started. Can anybody tell me what type of bond this is here? What type of bond is that? Very important, probably the most important bond in biochemistry. What type of bond is this? Does anyone remember? This is an ester bond. That's an ester bond. It's going to keep coming up. It's going to continue to come up. Okay. Now, I'm going to ask you another one. That's the yellow one. What about this green one here? Okay. I forgot my H's here. What type of bond is shown in green here? A P double bond O-O-R. A phosphoester. A phosphoester. And so this is a phosphoester. Does that make sense? Now, I'm going to throw a loop to you here. What type of bond is this one here? Double bond, P double bond O, O, and, well, the R is going to be some sort of, there's going to be a C there. What type of bond is that going to be? Okay, you skipped ahead. This one, okay, but that's good. This one here, this is still a phosphoester. This is a phosphoester. There's a phosphoester here, and there's a phosphoester here. But both of them together, both of these bonds together, make two phosphoesters. And what do we call two phosphoester bonds? A phosphodiester. And so this is a phosphodiester. A phosphodiester. And so there's going to be a phosphodiester linkage that attaches the phosphatidic acid to whatever the R group to make the different phospholipids. Okay. Everyone okay with that? Now let's look at our 8 phospholipids. Okay. We're just going to do Okay. Now what I'm going to do here, I'm going to do a rough drawing of them first, the 8 phospholipids. Okay, I'm going to put, well, sorry. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay. My tails on all of them. Okay, I've drawn 8 structures here. Can anybody tell me what each structure is? Yes, each one of them is a phospholipid, but what is the name of each phospholipid? Phosphatidic acid, exactly. So, we already have the name of the first one. The first one is going to be phosphatidic acid. So, I'm going to put here phosphatidic acid. So, that's the first one we already have. Now, if you add a choline group here to make the whole circle, if we add choline here, we can add a choline. Actually, has anybody written that one yet? Yes, they have in pen. Okay, so if we add choline here, then this phospholipid, what would we call this phospholipid if it has choline attached? Phosphatidylcholine. So phosphatidylcholine is going to be the second phospholipid that we'll learn the structure of. Now this is not the chemical structure of phosphatidylcholine. These are just drawings, just lollipops and half circles. Make sense? Very good. What if the head group here had ethanolamine? Ethanolamine. What will we call this phospholipid? Exactly, phosphatidylcholine. ethanoamine. So that's going to be the second phospholipid that we'll learn. The third one, rather. And you can see they're all based on phosphatidic acid. Does that make sense? What if we were to put here an amino acid? Let's put a specific amino acid. Let's put serine. Does anyone remember either the side chain of serine or the, what was it, the association phrase? Anybody remember it? Say that again. No, that's cystic. Yes. Methanol causes serious blindness. So the side chain of the R group of serine is methanol, and we'll see that in just a second. So here we have phosphatidic acid with serine attached. What are we going to call this phospholipid? What are we going to call this? Phosphatidylserine. Phosphatidylserine. And so how many phospholipids do we need to learn? 8. How many have I given you the name of? 4 of them. So how many are left? Makes sense. Makes sense. Okay. Let's do another one. On some of them, we can attach an inositol. Remember phosphatidyl inositol bisphosphate PIP2, and we cleave it to make IP3 and DAG in signal transduction? You remember that one? And so that was a phospholipid, and this is where we're going to learn its structure. So we can have inositol. So what's going to be the name of this phospholipid? Phosphatidyl inositol. I'm going to move everything up just a little if I can. Doesn't want to move up. Oh, there it is. Okay, there we are. Excellent. Okay. Let's do another one here. Okay, now this may confuse you, so I'm going to go back to show you something. Okay. I'm going to circle in gray here this molecule in gray. Okay. Does anybody know what's the name of this 3-carbon compound in phospholipids? Does anyone remember the name of that 3-carbon compound that our fatty acids are attached to? Glycerol. That is glycerol. Okay, that's glycerol right there. Okay, so phosphatidic acid has glycerol in it. Make sense? But now we're going to do something else. Not only does phosphatidic acid already have glycerol in it, so I'm going to put here 3 carbons here, 1, 2, 3, to represent glycerol. But it also, some phospholipids, as their head group, they have glycerol. So there are two. There's a 2 fatty acids, glycerol, phosphate, and then another glycerol. And so now we can give this phospholipid a name. What would you want to call this phospholipid? Phosphatidylglycerol. Phosphatidylglycerol. So phosphatidylglycerol has 2 glycerol molecules in it. One in the phosphatidic acid and one in the head group. No, you don't call it diglycerol. Because the glycerol that's in the phosphatidic acid is already a part of the base compound, the parent. Now this next phospholipid is going to be it's going to be the strangest thing you've ever seen in life. Well, maybe not. I guess I'm making it more dramatic than it really is. But now, not only, I'm going to put here 3 C's. 1, 2, 3. What's that 3-carbon compound in phosphatidic acid? Glycerol. I'm going to put one here. 1, 2, 3. What's the name of that one? Glycerol. But we're going to do something very strange here. What we're going to do here, the head group is going to be going across 2 phosphatidic acids, and it's going to be glycerol also. Wow. Wow. So now, what are we going to call this? Say that again. Diphosphatidylglycerol. Exactly. Wow, I didn't think you all would get that one. You all have impressed me. Diphosphatidylglycerol. Now, this phospholipid, this strange phospholipid, was first found in cardiac tissue. And so they gave it the name that has to do with cardiac tissue or heart tissue. They named it they called it the cardiac lipid. But they said, well, that name is too long. And so they decided, let's just call it cardiolipin. The cardiolipin. So that's the name of that phospholipid. So the last 2 phospholipids that you have to know are really just one, because it's 2 phosphatidic acids together. So really you only have to learn the structure of 7 of them. Make sense? Okay. So that's what today is going to be devoted to, learning these structures. We already know one of them. Which one do we already know the structure of? Yeah, we already know this one. So we only have 6 to learn. We already know this one. We only have to learn 6 more. So let's learn these. Okay? And when I draw these structures here, this is what I want you to be able to do on the test. Instead of drawing, I'm not going to draw the phosphatidic acid part. So when you draw these on the test, you don't have to draw phosphatidic acid, because that'll be on another question. So right, only that one. So now when we learn the phospholipid, I'm going to just draw this. This is going to be phosphatidic acid. It's going to be phosphatidic acid.
Where does it connect onto the phosphatidic acid? Onto that where the R is?
Right, where the R is. Where the R is. So just for this first one then, just to make that clear, what I'm going to do, I'm going to put O, P, O. So I'm going to actually show you the phosphate so you can see the connection on this first one. This is going to be phosphatidyl ethanolamine. We're going to do ethanolamine first. Okay. So ethanol, ethanol is CH2, CH3, CH2OH. That's ethanol. Okay. I should have put that on the other side, so it'll be. I'm just gonna do something real simple here. Don't let this frighten you. I'm gonna put the OH over here. CH2, CH3. That's ethanol. Everyone okay with that one? Now, ethanolamine is going to be CH2, CH2, but then we're going to put an amine group, NH2. But most of the time, there you are. This is ethanolamine, because it's ethanol with an amine group attached. Make sense? Now we're going to just attach ethanolamine to phosphatidic acid. So we're going to attach it right here. CH. I'm going to make ethanolamine a different color. CH2, CH2, NH. And in biological systems, most of the time, ethanolamine is protonated. And so that's the phospholipid phosphatidyl ethanolamine. It's often abbreviated PE. So of our 7 phospholipids, we now know the structure of 2 of them. And so the only thing you need to remember is what ethanolamine looks like, because you already know phosphatidic acid. It's going to always be that one. So it's really the only thing we're learning of the head groups, because you know what phosphatidic acid looks like. Make sense? Now let us move on to our third phospholipid. Everyone okay with that? Yes, question? Remember, there was basically here what happened, there was a nucleophilic attack here. Or really, it was actually this, this OH, these electrons here, attacked here. And when they attack, you lose this O basically on the phosphate. Remember when we make our glucosides and the alcohol attacks that carbonyl carbon? That's a nucleophilic attack, and you lose that O. So you don't lose the O on ethanolamine, you actually lose the O on the phosphate. Make sense? Okay. So that's phosphatidyl ethanolamine. Let's go to our next phospholipid. Now, what I'm going to do here, I'm going to draw ethanolamine again, because if you remember, this is the best way to remember this one. I'm going to actually draw this one another color. CH2, CH2, N. Now you don't draw this part, because I'm going to erase this. Now, what's the name of this molecule? Ethanolamine. Ethanolamine. But what I'm going to do here, I'm just going to get rid of all of the H's on the amino group. And I'm going to put CH3. I'm going to put methyl groups. CH3, CH3. And so now this molecule is called NNN trimethyl ethanolamine. But you don't need to know that, because that's ridiculous. And so we just call this choline. That molecule is choline. So choline and ethanolamine look very similar to one another. Instead of 3 H's on the amino group, you have 3 methyl groups on the nitrogen. Make sense? So now if I were to draw the structure, I'm going to put here. Now this time I'm not going to put, if it's okay with you all, I'm not going to put the phosphate. I'm just going to, because you know the phosphate is there, so I'm not going to put it. I'm just going to do, I'm going to just put choline, CH2, CH2, and CH3, CH3, CH3. So what is going to be the name of this phospholipid? Phosphatidylcholine. Phosphatidylcholine. Well, no, it's not protonated, because you replace all of the protons with methyl groups. Because remember, nitrogen has 5. And so you can put a bond if you put something here. And so if it's already attached to, it's already attached to the R group here, that's that. And so that's normal. Now if you add something else here, like CH3, it brings its protons along with it. And so that gives it a plus charge. Whenever nitrogen is attached to 4 things, it has a plus charge. Because it only has a valence of 3. Well, it has a valence of 5, it only has 3 lone electrons. Kind of makes sense? So how many phospholipids have we learned now? 3. How many do we have to go? How many more remaining? 4 remaining. Okay. Let us go to another one. I need to make me a lot of blank pages. Okay. Let's see what's going to be next. Okay. I'm just going to draw this structure because you already know what serine looks like. Let's do this then. Let's draw. I'm going to draw serine. NH3. Actually, let me do something because I want to show you all something. I'm going to show you all something that's really strange, almost, kind of. So I'm going to put here. I don't know how I'm going to do this. Well, let's do this. Let's do it this way first. I'm going to put NH3, C alpha carbon, COOH, hydrogen, and then seriously, methanol causes serious blindness. There's our methanol group. And so, what's the name of this amino acid? This amino acid is serine. Okay? Now I'm going to do something else. I'm going to draw something. I want you all to tell me what this is. Okay, I'm going to put it in green. HO, CH2, CH2, NH, H, H plus. Okay? What is the name of this molecule? Ethanolamine. Ethanolamine. Now, I'm going to do something. What if I get rid of one of these H's here and I carboxylate ethanolamine? What is that? Serine. Exactly. So if you remember ethanolamine, you can go to choline and you can go to serine very easily. Make sense? So now, if we were to draw our phospholipid, CH2, CH2, NH3 plus, and COOH. What's the name of this phospholipid? Oh, right. I deleted. Oh, yes, it's deleted because I deleted it up there. Make sure I got it right. Okay. So this phospholipid is phosphatidyl serine. So phosphatidyl serine, phosphatidyl ethanolamine, and phosphatidyl serine. Serine, ethanolamine, and choline. They're very closely related to one another. Okay. What do you think this would be abbreviated? PS? Did we abbreviate the other one? Exactly, PC. And did we abbreviate the first one? Yes, PD. Okay, so how many have we learned? 4. How many are remaining? 3. Okay. Let's do the next one. Now, this next one is not going to be like serine at all. We talked about inositol before. I don't know. You're going to have to just remember inositol. I hate that. So, inositol has a cyclohexane ring. It almost looks like a sugar, but it's not. And so, the best way to remember inositol is this. I'm just going to draw inositol. On the left side, all of the OHs are down. And on the right side, there's going to be one exception. But on the right side, you can think about it like this. So I wouldn't write anything yet. Just, okay, I'm going to put on the right side. All the OHs are up. Okay, but One of those is wrong. But if you can just remember this, inositol. On the left side, all of the OHs are down. On the right side, all of the OHs are up, except for one of them. Except for one. And so if this was a sugar, this would be carbon 1. So it is number 1. Except for 1. 1 is down. And that's inositol. And so, to make phosphatidylinositol, I guess I'll draw it over again. Yeah, I guess that'll be easier for you all if I drew it over. Okay, that's phosphatidic acid. And it's going to attach to, it's going to be this O that's going to attach. So, I don't have room. I need to raise this up. I'm going to put it up here. So all of these are down. All of these are up. Oh, no. All of these are down. So all of these are down. And all of these are up. Except for this one is down. No. This is O bonded to the P because I'm not putting the P anymore. Unless you want me to. If that'll make it easier. I'll put the P there. So it's always a phosphoester linkage. So if you go back here, this O here is connected to the P. If you go back here, this O is connected to the P. And here, I drew it explicitly here, this O is connected to the P. But I told you in the future I won't draw the P anymore. Just drawing the O of it. So you'll know where the linkage is. Okay? And so this phospholipid, if you want to give it a good name, what would you call it? Phosphatidylinositol. And phosphatidylinositol is involved in signaling. PIP2 is cleaved to IP3. And IP3 releases what cation? What cation does it release from the endoplasmic reticulum? Calcium. Remember? Excellent. It's all coming together. Now we have to abbreviate this something. So we can abbreviate PN maybe? PI would be better. Yes. PI. Phosphatidylinositol. How many more are remaining? 2. Only 2 more left. Okay. Now for this one, I don't really have to do anything because it's going to be glycerol. So you already know what glycerol looks like. So I can put here O and CH2OH, CH2OH. Well, this one doesn't have, just has CHOH. And so this is, because you already know what glycerol looks like, I don't have to draw it by itself. Correct? So this is phosphatidyl glycerol. How would we abbreviate this one? PG. Everyone okay with that one? How many are remaining? 1 left. Looks like we might get out of here early today. Okay. So we're going to have phosphatidic acid. We're going to have 2 phosphatidic acids on this one. And they're going to be connected by what? needs to be 2. Oh, 1, 2, 3, 4, right? CH2. Bless you. So we have 2 phosphatidic acids connected to 1 glycerol. Question. Oh, on the middle one. Is that? Yes, just CH, right. Exactly. Y'all are sharp. Oh, let's go back. This one? Where? On this one? Oh, because this is the other OH. The other OH is connected. This would have been the other OH for glycerol, but it's connected now. Yes. So, what's going to be the name of this phospholipid? Diphosphatidylglycerol. And there is no abbreviation for this one. It's just, but it has another name. Does anybody remember what the other name for it is? Cardiolipin. Why is it named cardiolipin? Exactly. It was first discovered in cardiac tissue. And those are all of the phospholipids. Where are phospholipids found? Very good. Okay, if you would close your notes. We haven't done this in a while. Yes, phospholipids are found in cell membranes. Yes. Okay, question 1. What is the name of the bond? What's the name of the bond between the glycerol of a phospholipid and what's the name of the bond between, in something like phosphatidylethanolamine, what's the name of the bond between the glycerol and ethanolamine? What type of bond is that? A phosphodiester, exactly, because that phosphate is joined to 2 things, exactly. What's the name of the bond between glycerol and the fatty acid? That's an ester. Very good, very good. What is the parent molecule of all phospholipids? Phosphatidic acid. What is the name of the functional group when phosphatidic acid is attached to something else? What is the name of that? Okay, when you attach methane to something else, what do you call that CH3 group? A methyl group. So when phosphatidic acid is attached to something, what do you call that functional group? Phosphatidyl group. That's why it's called phosphatidylethanolamine. Phosphatidyl. Very good. Let's see here. There are three phospholipids that have a common backbone, CCN. What is the name? What 3 phospholipids have that common backbone in their head group?
Phosphatidylglycerol, or non-phosphatidylglycerol, and phosphatidyl.
No.
Serine.
Phosphatidylcholine, phosphatidylserine. No. Phosphatidylethynolamine. They all have that common backbone. Okay. This phospholipid. Oh, starting from carbon 1 of inositol. Or tell me which OH is in inositol. It's a cyclohexane. Which OHs are up? Which OHs are down? They're up on the left. Correct.
And all down on the right except for one.
And they're all down on the right except for one. I Thank you all.
That was reversed.
Yes, that's going to be reversed. Exactly. Exactly. They're all down on the left. They're all up on the right, except for one is down. The last one. There's a very special phospholipid that has two phosphatidyl groups attached by glycerol. What's the name of that phospholipid? Diphosphotylglycerol. What is another name? Cardiolipid. Why is it so named? Found in cardiac tissue. Very good. You all seem to have understood. You all have a great day.